So pre-calc day 2 of lesson 1.4. Right now we are going to add, subtract fractional expressions, aka just add and subtract fractions that have variables, polynomials. So I got a 4-step process there for you. Should work for all of them, I hope. And that would be number 1. Factor all the numerators and denominators. That's no different than when we were simplifying fractions, when we were multiplying. The difference is that when I add or subtract fractions, I need to have a common denominator. So find the LCD and multiply each fraction of the missing by the missing parts to create that LCD on the bottom, but you have to do that to the top and bottom. So what you do to the bottom, you do to the top. Yeah? And then proceed to add and subtract the numerators as normal. I have in there to watch for negatives because the negatives are the ones that are going to mess things up for us. We'll forget to distribute that negative in. So I'm going to skip over the first example and we'll go into the second one. I'll make it a little bit larger here. So we'll do the second one here. And first step was factor everything. Do I need to factor the numerators? No. So I just have to worry about the denominators here. And I think we should all agree that this would be 1 over what? A lot of this, I think, in the last couple of days. Difference of squares, x minus 1, x plus 1, and minus 2 over x plus 1 and an x plus 1. Do not FOIL those together. That would be nonsense. You'd have to break it apart to use it. So, what I like to do when I say find the LCD is actually write LCD equals. I want you to state what the LCD is. So, how I like to do this is I look at the first denominator. The first denominator, I write the whole entire thing. Because the first guy to the party, what do you call when you bring a dish to pass? Potluck. We're going to a potluck. The first guy, he wants to bring, because we all know at potlucks you don't want everybody to bring a pan of brownies, because that would just be one horrible potluck dinner. Yeah, right? Nice dessert bar. But he gets to bring everything he wants to. Okay? The first guy who arrives, if he wants to bring a pineapple and an orange, he can do that. Okay? The second guy, we don't want more pineapples and oranges. We can only eat so many. So he's got to bring something different. But the thing is if he's got 2 of something or 3 of something, he can bring the extras. That's the way I kind of think of the LCD. Does that kind of make sense to you? Like, if everybody wants to bring 1 of everything, they can't. Only the first guy can. But the next guy, if he wants to bring 2 of that same thing, he has to leave 1 outside, he can bring 1 in. That's the way I kind of look at it. So the first guy's bringing an x minus 1 and an x plus 1. And the next guy wants to bring an x plus 1 and an x plus 1. Is he allowed to bring both of those along? He can't bring the first one because we've already got one. So we look at the second one. Hey, he's got another one. Yeah, he can bring that. So, we will do that for all of the denominators. In this case, there's only 2 of them. And there we have our LCD. If you wanted, you could put that back together a little bit with the x plus 1 squared. You got to have the most of every factor, right? That's what it comes down to. So, how can I take that and make it look like the bottoms here look like this bottom? I just multiply by the missing piece, x plus 1. I'm going to put this up front, over on this one. But what I do to the bottom, I have to do to the top. And the second one, I'm missing the x minus 1. And this the first problem would be the exact same way. The reason I want to do this one is because of that negative sign. I'm going to multiply. This one is not too bad because it's 1 times x plus 1 on top. That's x plus 1. On the bottom, ladies and gentlemen, I repeat, I am not going to FOIL, multiply, or anything. I'm leaving it in factored form. The second one, I will, though, on top, distribute through. Now, the question is, when we have a negative here, we have options, because that negative has to be taken care of. Either I do it in one step, or I have to do it in 2 steps. So I can distribute the 2 to get 2x minus 2. But if I do that, I will have to still distribute the negative at the end. So I propose that you change it to a plus and just make the 2 negative. You're less likely, if you turn it to a positive or addition, that I'll make a mistake when I go to distribute. So in that case, I know I'm going to add, and all I'm going to add is negative 2 times x, negative 2x, and hopefully plus 2, and that is over x plus 1, and x minus 1. Yes? Now you got common denominators. Gather like terms on top. I think we're at the step point now in our careers that we don't have to write x plus 1 plus a negative 2x plus 2 all over the denominator. Can we do that right now? Can we just put it together? I'm hoping you guys say yes. Yes. X and negative 2x will give you what? Negative x. So it's a negative x. And then it's 1 and plus 2. It's plus 3. And this is all over. Does the denominator matter its order? No. Now, maybe to make it a little bit more efficient, you would do what with the denominator here, though? The rest of the way you didn't need to, but here maybe. Yeah, make it x plus 1 squared. Just to be maybe a little bit on the picky side. I know I said not to do anything yet, but maybe you should, for the most cleaned up version, maybe write that. So the biggest thing people make mistakes on is that negative sign, and they forget that a negative is either goes to the top or it goes to the bottom. It can't go to both. You guys made those mistakes in freshman year. Don't make those here. And then you can distribute the negative in, change it to positives. It's awesome. The next one is compound fractions. We've always learned it as complex fractions, aka fractions within fractions. So, again, factor all the denominators on this one. You don't need to take the numerators. You need to factor the denominators. You still need to find the LCD. So today the key is LCD, least common denominator. And then, there's 2 different ways you could do this. The book shows one method of flipping the fraction and multiplying. I don't necessarily like to flip and multiply. I like to use the second method the book uses, and that is multiplying the larger fraction by the LCD over 1 divided by the LCD over 1. I'm going to multiply all the numerators, all the tops of the fraction, the larger fraction, by the LCD. This in one step will simplify your fraction to just a normal numerator denominator. It's pretty cool. So the first example we're going to deal with looks very much like problems you had to deal with in GeoTrig. So it's just 1 over a plus h minus 1 over a divided by h. So I'm looking at 4 fractions going on here. I don't know if you guys can see that, but it looks like I got 1 here with 1 over a plus h, 1 over a, h over 1, and then the larger fraction bar, which is 4. We want to get to 1 fraction. So, step number 1 says factor all your denominators. Are they factored by chance? I think so. I think I can put a 1 over here, so I know that there is a denominator there. Then, all I have to do is find the LCD. What's the LCD of this problem? What's the first fraction bottom? A plus h. He gets to go bring an a plus h. The next guy to the party wants to bring a. Can I bring an a or not bring an a? Is a there already?
Yeah, he's already there.
Ooh, he's not.
He's not.
And a plus h is already there, and a is not. They're different factors, remember? And h wants to bring a 1. Well, 1's already there, right? It's implied. There's always a party of 1, right? So there is your LCD. This is how it's going to work, or maybe I should have made it a little bit larger. Is that I am going to multiply the numerator and the denominator by a plus h times a over 1. A plus h times a over 1. I am going to multiply it by 1. Because if you think about it, that's a fraction. If I divide those out, it's just 1. So now I'm going to distribute it in. On top, on the bottom, not so much. It's just 3 terms multiplied, really easy. So let's start with the denominator there. The denominator, there's nothing cancels on the bottom, right? Nothing cancels over here. So it's just a, h, and then a plus h. Is everybody okay with that? A, h, that might be too big. Okay. A, h, and then a plus h. That's your denominator. What's your numerator look like? If you notice, I have to distribute this in. And when I go to distribute the a plus h a in, it cancels with the a plus h on the bottom, leaving you with a minus, because there's a negative sign there, subtract, and what cancels on the second pass? So you're left with the quantity a plus h. Ooh, we are not done, are we? What do I have to do now? Distribute the negative in. A minus h all over a h, a plus h. And you guys recognize things will happen here. What happens? Yeah.
On the top, the a's cancel.
Yeah, the a's cancel, leaving us with negative h over ah, a plus h, and we're done. And if you just put your pencil down thinking, yep, you're not done. You're not done. What else can be done? What's that?
I just said factor out a negative.
I don't want to factor out negative.
You should leave the AH in.
I do not want to put the AH in, because if I do that, then I would have to factor it back out. What's on top? What's on bottom? An H. Guys, it's negative 1 times H. They're all multiplied on top. And then it's A times H times A plus H. Why can't I cancel the H's? Get the H out of here. Oh, that was good. Okay. So, you end up with negative 1 over A times A plus H. You are done now. The next one, you guys are thinking, Mr. Konchak, we're good. This is just a fraction. And then I'll say, no, it's not. Why? What do we have? There's something we don't like about it. There's a negative exponent. So that negative exponent has to go to the bottom. But here's the problem. There is a negative sign or subtraction going on. So therefore, this negative exponent that's right here only goes to the bottom of this individual fraction. He doesn't get to go to the basement of the whole thing. So you'd have to rewrite it as 1 plus x squared to the 1/2, is it? Minus x squared over 1 plus x squared to the positive 1/2 now, all over 1 plus x squared. Can we write these guys over 1 though? No. We have to factor it. Do we need to? No, particularly this time it's not factorable. It's already done for us. It's already grouped up. What's the LCD without even having to do much fanfare? It's the 1 plus x squared to the 1/2. So that's kind of nice. So now all I have to do is say, hey, I'm going to multiply the top and bottoms by that. Now think back to the problem we just did. I multiplied it to the top and to the numerator and to the denominator as a numerator, to the top of a fraction, right? And then on top there were multiple terms, just like this problem. I ended up distributing whatever I had on the outside into the fraction, yes?
Yes.
If I had the same thing on the bottom with pluses and minuses, I would have had to distribute there as well. So instead of saying, oh, just multiply it to the top and bottom of the fraction, what if I just multiplied it to all of the individual fractions? So why couldn't I just take that LCD that we are saying is this thing and multiply it to every term? Notice that I'm going to have to squeeze it in this one. But basically, I'm multiplying to the numerators of all of these fractions. So hopefully you see that it will automatically do what with that one. The reason I like to do it this way is so that you can actually cross things out. Because on the last problem, if I would have crossed things out, then some people would be like, oh, it's gone. I don't need to keep going. But you have to multiply it to all of them. The others don't have denominators. So therefore, we have like bases being multiplied. We do what to their exponents? You add them. And so now, this one becomes, the first one, it's 1 plus x squared. And that's it, isn't it? Or we say to the first power because a half plus a half. Minus x squared because there was an x squared attached to it. And the bottom is still 1 plus x squared. But what is it? What power? What's 1 plus a half? It's 3/2. I would almost think that we could clean the top up. Do I need the parentheses on that first group? What's going to happen? X squareds cancel out, so you're left with what on top? And to the 3/2. Everything's got positive exponents. Everything's factored. We're happy. Next, we're going to talk about rationalizing the denominator or the numerator. Now, in our problems, I got one of each. I'll again make those a little bit larger here for us. If the numerator or the denominator has this form here of a plus b times the square root of c or a minus b times square root of c, you rationalize it by multiplying both the numerator and the denominator by the same exact thing, but opposite sign. Again, we've done that before. And so, we look here, and we can multiply. So we're going to multiply the first one by what?
1 minus 2.
Yeah, 1 minus the square root of 2, but what I do to the bottom, I need to do to the... If I just multiplied by a square root of 2, because the square root of 2 times square root of 2 is 2. It would get rid of the square root of 2, but I would have to distribute it all the way across, and then I'd have 1 times square root of 2, which then still leaves me with a square root of 2. It's okay to have square roots on top, just not on the bottom, but we have to realize that you can take them from the top and get rid of them to the bottom as well, and that will come in handy in the future for you guys. And obviously this one's not too bad because 1 times something is that's something, so the top just stays 1 minus square root of 2. But guess what? The bottom, guys, you set up the difference of squares, and so you know that's the first one squared, so 1 squared minus square root of 2 squared, right? Which then equals 1 minus square root of 2 over 1 minus 2. And 1 minus 2 is, so 1 minus square root of 2 over negative 1, which then can lead us to what? Yeah, question?
Yeah. Would it not be
So we're going to bring the negative 1, so therefore it is negative 1 plus the square root of 2. I think that's a lot easier to look at than 1 over 1 plus the square root of 2. Personally, whether we consider that rationalized or not, I think it's just more simplified. The last problem I do believe that we are going to do is the square root of 4 plus h minus 2 all over h. We just multiply the top and bottom by 4 plus h plus 2 to the top and bottom. I like to sometimes put parentheses around all of these as well, just so you know that on top you will have to FOIL, the bottom you will have to distribute. Now, in essence, to save time, I'm not going to distribute because then that h is going to be floating around down there. Let's just leave the h out front. Is that okay? So h times the square root of 4 plus h plus 2 is on the bottom. But the top definitely needs to be FOILed because that's the whole reason of getting rid of the square root. Square root of something times square root of something is that something. Make sure to leave it inside that parentheses, just for now, because it's the whole group. And then it's the square root of 4 plus h times 2, which means you have how many of them? Oh, wait a minute. You have 2 of them. But then you go back and put a negative 2 of them. Just cancels. I'm not going to mess with that. And then, because we're doing this on purpose. We're engineering this to happen. And then just do negative 2 times 2, which is minus 4. And now, if you want to clean that up, you get 4 plus h minus 4. What happens? H over, oh wait. Yeah. And to be honest, I did not personally think that was going to happen. And it's not why a reason I left it out front, but is that always an option that things could cancel? Yes. So you end up with 1 over the culprit, right? So I'm assuming at some point we started off with a problem that looks like the answer here and said, hey, we don't like to have the square root on the bottom, which then created the one on top, the original problem. But you guys can see that you can go both ways on these. I can get rid of it out of the top or the bottom by multiplying essentially the same thing. So the last thing I want to talk about is just those common errors that people make. We got the correct multiplication use of the property, and then we have the do not do, right? So this one, again, is the power of a product. That's why you can bring in the exponent. But this is a power on an addition or a sum. That's not a squared plus b squared. Guys, you'd be amazed at how much I see that as a teacher, even in pre-calc. So please don't do that. Same thing as if you're square rooting here. Fractions don't just get to add together. You got to have the common denominators. And notice that you can't just cancel a's. That's the side that I really want to focus on, is the stuff you can't do. So make sure you are not doing those things. And I think most of us by now have already been kind of scolded on making some of those mistakes, so we don't make them again. But kind of look at those and say, those I cannot do, and this is the reason why. I'm trying to use this, but I end up using it in a way that I can't. We call that sometimes voodoo math, right? Stuff that you can't do. Homework, guys, is on chapter 1.4, day 2, page 43, 15 through 75, every 4, and problem 79. Have a great day.